Welcome to Grateful, where we are working on College Board's SAT Test 5, Section 4. Grateful can help you pursue your SAT and ACT goals and help you try to get into your dream college. We could be tutoring you online as early as today. If you're interested, go ahead and reach out. Let's go ahead and get started with Section 4 right now. According to the graph above, between which 2 years was the greatest change in the number of 3D movies released? Okay, so the greatest change, when we talk about change, that's a loaded word on the SAT, that's slope. Slope is your change in Y over change in X. So we're basically talking about where was the greatest slope. And here you have a flat slope of kind of like a slope of 0. Here a little bit greater, here it goes down a little. Here's a negative slope. Now here it starts to really increase the most, and it decreases from there. But very clearly, this is the one area where the slope is the steepest on this graph. And so that's going to be the place where there was the greatest change. So that's from year 2010 to 2011. And the answer is D. Now, once again, how did we know that was the one? It's the most steep. If I were climbing a mountain, this would be the place where I'd have the toughest time climbing. Let's go ahead and look at number 2 now. Some values of the function are shown in the table above. What defines f? Okay, well, first of all, they're telling us it's linear. That's very important because it could be exponential or something else. But a linear is a y equals mx plus b. And the slope of a linear, we just said, is the change in y over change in x. But if you're given the points, which we are here, then you might want to lean toward the slope formula, y2 minus y1 over x2 minus x1. Another important thing to notice here is that f of x is just a fancy way of saying y. So the left column is the x values, the right column is the y values. This table can be compared to if they had given you just these 3 points, but giving it in the table with the f of x terminology can definitely make it seem a little more complicated. So if I'm going to use the slope formula, I can just pick any 2 of the points, and maybe the easiest way for someone who's beginning with slope is to label them x1, y1, x2, y2. Now there's no doubt when you go to plug it into the formula, which is the slope formula right here. And so let's go ahead and plug that in. So y2 minus y1, 13 minus 5, over x2 minus x1, 3 minus 1, will give us 8 over 2, which simplifies to 4. And the only choice that has a slope of 4 is going to be choice C for number 2. Scrolling down to number 3 now. Question number 3 says that we need 2.5 ounces of chocolate for a muffin. How many pounds will we need for 48 muffins? Okay, so we're dealing with unit conversions. We can see they're giving us unit changes in parentheses and so on. But there are 2 types of unit conversions that I would like to make you aware of. One would be a unit conversion of a value, and another one would be a unit conversion of a rate. So for instance, I could say we are going, 10 feet per minute. And I could say, okay, well, how many miles is that per second? Well, there are 60 minutes, or actually we're converting to seconds. There's 1 minute and 60 seconds. And there's 5,280 feet in 1 mile. So the idea is that the units cancel, just like if you had X on the top or X on the bottom. Feet cancels with feet, minutes cancels with minutes, and you can see that in the end of this, we'll have miles per second. So here we started with a rate and we're ending with a rate. But in the question that we have here, we're starting with a value, and the value is 48 muffins. And we need 2.5 ounces per muffin, ounces of chocolate, and 1 pound is 16 ounces. So as we explain frequently on this channel, these unit conversions are each equal to the number 1. Because if it takes 2.5 ounces for one muffin, then they kind of have the same value. For every 2.5 ounces of chocolate, I'll get 1 muffin. For every 1 muffin, I'll get 2.5 ounces. So the idea of the number 1 is that these are like the fraction 5/5. And when you multiply by the number 1, nothing happens. So it's a pervasive theme throughout the SAT. You may see complicated situations which are essentially asking you to realize that A plus B over A plus B is also the number 1 or something more complicated. So we take advantage of the fact that when you multiply by 1, nothing happens. So muffins cancels with muffins, ounces cancels with ounces. The only unit remaining is pounds, which is perfect because the question asked us how many pounds are needed. And now we can just go ahead and multiply the top and multiply the bottom. So we're going to have pounds as the remaining unit. And in the numerator, we'll have 48 times 2.5, whatever that is, which is 120. And in the denominator, we'll just have the number 16 there. And so we have 120 divided by 16, which is 7.5 pounds. And therefore, the answer to number 3 is going to be A. Now we're going over to number 4. So number 4 is one of these questions where we don't need to find C or D individually, and actually we can't. It's more a question of, it's what we refer to as corralling, which is the idea of making what we have turn into what we want. So what we have is 3 parentheses C plus D, and by the way, that equals 5. But what we want is just C plus D. So what's happening to the C plus D? It's being multiplied by 3 initially. So the opposite of multiplying by 3 is dividing by 3. So we can divide by 3 on both sides of the equation. And so now on the left-hand side, that gives us C plus D. And on the right-hand side, that gives us 5/3, which is choice B for number 4. Now we're going to number 5. The weight of an object on Venus is 9/10 of its weight on Earth. The weight of an object on Jupiter is 23/10 on Earth. Okay, so Venus is 9/10 of Earth. Jupiter, excuse me, is 23/10 of Earth as well. And the object weighs 100 pounds on Earth. So we can take both of those equations. So we can take the top one. The weight on Venus is 9/10. Now Earth, the weight on Earth is said to be 100. So that comes out to 90. And the weight on Jupiter is 23/10 of what we have on Earth, which is 100. Now when we multiply this out, by the way, no need for a calculator. 10 and 100 cancel, leaving you with 10 right here. If you divide 100 and 10 both by 10, the 10 turns into a 1, the 100 turns into a 10, and 23 times 10 is 230. So the two weights on Venus and Jupiter are 90 and 230, and the difference between them would be 140. And we're continuing with SAT Test 5, Section 4, starting at question 6. So here we have a linear system of equations. And linear systems of equations will deal with 2 sets of items, usually, like dogs and cats, hamburgers and hot dogs. Here it's books, novels, and magazines. So we're usually going to be given the total number of each item, the total number of items altogether. But what we're not given has to do with each item. So when we're talking about linear system of equation word problems, we're looking out for price versus quantity. And what will be often given is the total price and the total quantity. That's this. But what we might need would be the price or quantity of each item. So you want to kind of have that in your mind and already be looking for it. So here, were we given the price of each item? Yes, we were. The novels are $4, the magazines are $1. So we just figured out through this process that X and Y are going to be the number of each kind of item. So we're talking about the number of novels and the number of magazines. So this process here of announcing to yourself what your variables are, what you're looking for, is perhaps the most important part of this process, because now you can think clearly and say to yourself, well, if X is the number of novels and Y is the number of magazines, then X plus Y is the total number of novels and magazines. And they told us that that's equal to 11. And then we have the total amount of money, and money will often be your price times your quantity. So for instance, we have X novels and each novel sells for $4. And we have Y magazines and each magazine sells for $1. So now we've got our two equations and two variables. If they line up like they do here, you have the X's, the Y's, and the numbers lining up. In that situation, the elimination method is often better. But if you can get one variable by itself very easily, which you also can here, then the substitution method is usually better. All in all here, I say the elimination method is the easiest one. And one more thing before we go ahead and do it, the question is asking us how many novels. So it's asking us for X. So that means that when we eliminate, it would be best to try to eliminate Y. And we can do that on purpose. All we need to do is multiply one of the equations by just -1. So we can do negative X minus Y equals -11. And look how easily this works out when you do that. Add straight down, 4X minus X is 3X, Y minus Y cancels, and 20 minus 11 is 9. So 3X is 9, divide by 3 on both sides, and you get X is 3. So the number of novels is 3, and the answer to number 6 is going to be B. Let's go ahead and move now to number 7. The Downtown Business Association is increasing its membership by N businesses. I'm looking for the units to see if they conflict. There were B businesses, and we're looking for the total number of businesses X years from now. So the Y value we're looking for is the number of businesses, and the X value is the number of years. Now we know this is linear because it's increasing by a certain number of businesses per year. So every time X increases by 1, Y is increasing by the same amount, but we need to figure out what that is. The basic structure that we see time and again on the SAT is Y equals MX plus B. We started with B businesses, but we're increasing at the rate of N per year in this problem. So the change in Y over change in X, the slope, is the letter N here. And so, which function models the total number of businesses X years from now? NX plus B, which is a nice and easy answer A on number 7. Here we are going through College Board Test 5, Section 4, question number 8. And we're looking for an equivalent form of the expression. So we just need to kind of simplify it out. So squaring the first part, squaring means multiplying it by itself. So 1.5x minus 2.4 times 1.5x minus 2.4. And we have a minus sign here. So we're going to distribute that into these two terms. So negative 5.2x squared plus 6.4. Now we're foiling this piece. First times first, 2.25 x squared. Outer times outer is negative 3.6x. Inner times inner is another negative 3.6x. And last times last is positive 5.76, I believe. Let's see. 5.76. Bring down everything else we have. Now we're combining like terms. So we have our x squared terms here. We have our x terms here. And we have our constants here. Constants are the numbers that don't have an x. So adding the two blue ones, combining like terms there, and we get negative 2.95 x squared. The two green ones, combining like terms, negative 7.2x. And the two pink ones, 5.76 and 6.4, are going to add to 12.16. So this answer matches exactly with choice C for number 8. In the 1908 Olympic Games, the marathon was lengthened from 40 to 42 kilometers. What's closest to the increase in miles? So what was the increase in kilometers? It was just 2 kilometers. And then the question tells us that one mile is 1.6 kilometers. So 1 mile is 1.6 kilometers. And so classic unit conversions that we see a lot of, you have kilometers on the top, kilometers on the bottom. They cancel just like a variable. By the way, like we always say, this whole thing is equal to the number 1 because you have 1 mile over 1.6 kilometers. If they're equivalent to each other, it's like the fraction 5 over 5 or x over x. It's just the number 1. And when you multiply by 1, nothing happens, which is why we're allowed to do this. And multiplying it out, you have 2 divided by 1.6, which is 1.25 miles. And the answer, number 9, is B. Now we have number 10. The density of an object is found by dividing the mass by the volume. So density equals mass over volume. Which equation gives the mass in terms of dmv? So the mass is this right here. We need to get the mass just by itself. So right now what's happening to m? It's being divided by v. So to get it by itself, we can do the opposite, multiply by v. That'll cancel on the right. So now we have the m equals d times v, which is choice A right there. So the answer number 10 is A. Now number 11, the graph of which of the following equations is perpendicular to the above equation? So if we want information about this equation, we're going to want to get y by itself, because that'll kind of automatically put it in a y equals mx plus b format where you can find out slope and things like that. So maybe add 2x to both sides, then divide by 3. So right now we have y is 2/3 x plus 2, which means that the y-intercept is 2, and the slope is 2/3. Now, perpendicular slopes are negative reciprocals of one another. So to get from one slope to the slope of something that's perpendicular to it, you need to flip the number upside down and multiply by -1. Which, by the way, so if my slope is 5, the slope that's perpendicular is -1 over 5, because the reciprocal of 5 is 1 over 5, and you multiply by -1. And if the slope were, let's say, -3, the perpendicular slope would be +1 over 3, because you're flipping it upside down and multiplying it by -1. Here, our slope is 2/3. So our perpendicular slope is going to have a 3 and a 2, and it's going to have a negative sign. So it's been flipped and multiplied by -1. So for which equation does that happen here? The only way to really solve that would be to go through all of them and do the process. But the one that should work when you do it is choice A. Because for choice A, if we take away 3x from both sides, you have that, then divide by 2. So 3 over 2 and 6 over 2, which is 3. So the slope is negative 3 over 2. So we went from a slope of 2 over 3 for the original equation to negative 3 over 2. And notice that they are flipped. They're reciprocals of one another. And there's a negative sign on the second one. So they are negative reciprocals of one another. And the answer to 11 is A. Now we have number 12 here. Okay, what's the value of x here? This, as far as systems of equations goes, I might consider to be a special situation because they're telling you that 1/2 y is 4. So if we know that 1/2 y is equal to 4, we can look at the other one and see that you've got 1/2 y right here as well. So wherever I see 1/2 y, I can replace it with 4. So x minus 4 is 2, and x is 6 when you add 4 to both sides. So that's just so easy that we can maybe do this question a little differently than how we normally do linear systems of equations. Going over to number 13 now. Which ordered pair satisfies the system of inequalities above? Okay, so satisfying is essentially the idea that if you plug them in, they'll work. So I'm just thinking to myself, would it be better to graph them or to just plug in the numbers? And I really think it might be better to plug in the numbers. So let's call this equation A, call this equation B. So equation A is here, equation B is here. And for each of the answer choices, we're going to judge whether it satisfies inequality A or inequality B. So for -2 and -1, so for choice A, for answer choice A, then we'll have -1 less than or equal to 3 times -2 plus 1. -1 less than or equal to -6 plus 1. -1 less than or equal to -5. Is -1 less than or equal to -5? No, -5 is less than -1. It's more negative. So inequality A is not being satisfied by choice A. So we're already done with that one. We don't even need to test out B. Okay, let's look at answer choice B and try inequality A. So answer choice B has -1 and 3. So y equals 3. 3 is less than or equal to 3 times -1 plus 1. So we're using the first inequality they gave us. And 3, and -1 plus 1. Okay, so we're just solving through. And 3 has to be less than or equal to -2, which is once again not true because 3 is greater than -2. And we're done with choice B. Answer choice C and inequality A, we can say, well, we have y less than or equal to 3x plus 1, and y is 5 when x is 1. So 5 less than or equal to 3 times 1 plus 1. 5 less than or equal to 3 plus 1, 4. Is 5 less than or equal to 4? No, 5 actually is greater than 4. So then choice C is done as well. So these are all kind of being eliminated nice and easily. So for answer choice D and inequality A, y less than or equal to 3x plus 1, and we'll plug in x is 2 when y is -1. So -1, 2, -1 less than or equal to 7. Is -1 less than or equal to 7? It is less than 7, so it works. So inequality A worked for choice D. let's try inequality B, which is x minus y greater than 1. So plug in x is 2 and y is -1. So x is 2 minus -1, little double negative in there, which is intended to make the question more difficult, I would imagine. And the double negative, 2 minus -1 becomes +1. So 2 plus 1 greater than 1. And is 3 greater than 1? Indeed it is. And both inequalities checked out for answer choice D. And so for 13, the answer is D. Okay, number 14 says a lot, but let's skip to the end of what it's asking. If one of the surgeons is selected at random. So one of the surgeons, is that the whole chart or just part of it? Type of surgeon. So they're talking about the entire chart. So one of these is selected at random. That's a big deal because on most of these questions, from what I've noticed, they're asking you to just pick out, it might say something like if one of the teaching surgeons is selected at random, which would mean we would limit it only to one of the columns, and that's called conditional probability. So here they're asking for all of the surgeons in general. Notice that I didn't highlight the totals because those numbers are included in the part that we have highlighted in green here. So if one of those surgeons is selected at random, what's the probability that that person is an orthopedic surgeon with an indicated professional activity that's research? So orthopedic, pick a different color for that. Orthopedic with research takes us to the number 74. So probability is the part over the whole. The part that they're asking us about here is the 74, and the whole is the 607. So we've got 74 divided by 607, which if you divide it on a calculator comes out to 0.1219. And if you round it to 3 decimal places, that would be 0.122. So the answer to number 14 is A. Now number 15. A polling agency surveyed 1,000 adults who were selected at random from a large city, asked them, are they satisfied with the quality of air in the city? 78% responded that they were satisfied. Okay, so which statement must be true? Now, first of all, this is our classic data collection question on the SAT. And when we have a question about data collection, there's 3 things to look out for. Number 1, we can make no definitive statements. So a definitive statement would be a statement that says, based on everything we know, this is definitely what's going to happen next. And it kind of violates the rules of science because science and social research and so on, they can only make really educated guesses. So based on research, we're never going to definitely know what's going to happen. We need a word like likely, approximately, it appears to be the case that, or something that takes the edge off of it being a definitive statement. Number 2, we don't want there to be any bias. Bias would be selecting a group of data that is already likely to have certain characteristics. So for instance, the example I always use would be, if I want to know people's opinion on golf, I wouldn't want to go down to a local golf course and start asking people, because those are people who already, by deciding to go to a golf course, there's a good chance that they like golf. And that would be an example of bias. And maybe the most important of these, and the most boring sounding, is the idea that you can only reflect on what you studied. So that sounds really obvious, but there's a lot of cleverness in the way the questions are administered. So for instance, if I want to know the opinion of all 3rd graders in the United States, then I should not pick 3rd graders from one class at one school in the United States, because then that can only be reflected to that class in that school at large. So if I want a sample of 3rd graders around the United States, I need to take a random sample of 3rd graders randomly picked from throughout the United States. So you can only reflect on what you actually studied. And so let's go ahead and look through the answer choices here and see which of these rules are being violated. In choice 1, it says 78% are satisfied, and that's of all the adults in the city. So if we took a sample of adults, we're not going to be able to say what is the case, the ones who are satisfied. I can only talk about my sample. Based on the sample, 78% were satisfied. So it would appear that of all the adults in the city, 78% would be satisfied if we used a word like it would appear. So this is the idea of the definitive statement. And 1 is definitely a definitive statement. To not be a definitive statement, it would have to say, it is likely that 78% of the adults in the city would be satisfied based on the chart, based on the research. So looking at number 2, if another 1,000 adults selected at random were surveyed, 78% would report. So once again, how do we know what would definitely happen? There is no way to know that. That's a definitive statement, and so that's bad for us. Number 3, 1,000 adults were selected at random, 78% of them, once again, would report. So we're saying in these 3 choices what would definitely happen, and there's no way to do that. We could say what would be likely to happen. So all 3 of these are definitive statements, believe it or not, and the answer to number 15 is A. So now we have question 16, and I'm just going to take an extra second to put the information next to the question itself. This is the hardest part of the life of an online tutor here. It's kind of getting things to show up on one screen. Okay, so the method of calculating the age, so the age comes when you multiply the diameter in inches by the growth factor. So just writing that out, age is diameter times growth factor, as long as the diameter is in inches. So let's go ahead and start using that. What is the age of an American elm tree with the diameter of 12? So the American elm has a growth factor of 4.0. So the growth factor is 4.0. The diameter is 12. Therefore, the age is 12 times 4.0. So it's 48. And the answer to number 16 will be D. Okay, going over to number 17. Okay, question 17. The growth factor of this species is closest to that of which of the following species of tree? Well, if the age is the diameter times the growth factor, that's actually similar to a y equals mx plus b, with just a 0 right here. And so when we talk about the growth factor, actually if we switch it around, we can think of the growth factor as the slope. And so in this situation here, your slope is your change in y over change in x. And look how this lines up with ours. The growth factor would therefore be the change in the age over change in diameter. So in other words, rise over run with age over diameter. So we're just confirming through this discussion that what they're actually asking us for is the slope in this situation. So what's the slope? When you're doing slope for a line of best fit, you want the amount of rise over run, but you also want to pick the points that are furthest away. So I might pick this point and figure out how much we're rising and how much we're running. And that'll tell us the slope. So now, the further away you pick your points, the more accuracy you're going to get. If I pick 2 points that were here and here, I'd have a much bigger chance of maybe overgeneralizing and getting a number that doesn't match the situation. So I want to stretch those out to 2 points like the green ones, the furthest possible points I could think of. So how much is it rising? It's going from, in my view, around 70, 75 to about 125, let's say. So it's increasing by 50. And how much is it running by? So I have it at 10.5 going to 16.5. So it's running by about 6. So what's the slope for me? It's about 50 divided by 6. And 50 divided by 6 gives you 8.3. So which of these is the closest to 8.3? This one right here, 7.5. And we'll go ahead and continue here. We have a white birch and a pin oak. They each have a diameter of 1 foot. Now, when we originally talked about the formula here, we said the age is the diameter times the growth factor, and the growth factor has to be in inches, or the diameter has to be in inches. Here, the diameter is given as 1 foot, so that needs to be changed. So we'll think of that as 12 inches, which is what they tell us here that 1 foot is, but most of us already know. And then we have the pin oak right here. So for each of them, the age is the diameter times the growth factor. They both have a diameter of 1 foot, which is 12 inches. And the growth factor of the white birch is 5.0. And the growth factor of the pin oak is 3.0. So with the given information in the chart and in the question itself, we can tell the two ages. So the white birch is 60 years old and the pin oak is 36 years old. So now the question says 10 years will go by. So the age is now, which age is diameter times growth factor, but the age is now 70 and 46 because they were 60 and 36 and 10 years have gone by. The growth factor for the white birch hasn't changed, so it's still 5. And for the pin oak, it hasn't changed, it's still 3. So now we can solve for the two diameters, divide by 5 on both sides, or divide by 3 on both sides. So we'll get here, the diameter is 70 divided by 12, which is 14. And here it's 46 divided by 3, which is 15.3. And what's the difference between them, which is what we're being asked for? It's 14 versus 15.3. So the answer to number 18 is C, 1.3. So looking at question 19, we're looking for the length of side AD. But looking at the information we have here, this triangle on the right-hand side, the degrees in that triangle need to add up to 180. So if we have 90 and 60, then that's 150 already, and we would need 30 more to get 180. Also, we have a pair of supplementary angles, better known as a linear pair right here. You have these two angles, the blue and the green one. They together form a straight line, and so they need to add to 180. If one of them is 90, the other one's automatically 90. And in the triangle on the right, because we have 30 and 90, those add up to 120 to make the triangle equal 180, we would need the third angle to be 60. So we have two 30, 60, 90 triangles. Now the 30, 60, 90 triangle ratio, it's given to you on the SAT formula sheet, I believe. But in any case, you should still know it by heart because you need to be quick with it. The 30, 60, 90 triangle ratio is x, 2x, and x root 3. So I remember that in an auditory sense, x, 2x, and x root 3. But I believe the most important thing to remember there is that the 60-degree angle is across from the x root 3. Because obviously 2x is going to be the largest, x is the smallest, x root 3 across from 60 is the middle. If you have that down, then you'll be able to always label a 30, 60, 90 triangle correctly. So now we have one side where a length is given, and the ratio that for that side is 2x. So we can say 2x equals 12. 12 equals 2x. Divide both sides by 2, and x equals 6. So now we know the value of x. We can plug it in there, and x root 3 is 6 root 3. So we have 6 here, 6 root 3. And we can take that over to the triangle on the left. It's got 6 root 3 right here, 60, 90, 30. And once again, across from the 30 is x, across from the 90 is 2x, across from the 60 is x root 3. So x root 3 equals 6 root 3. So dividing both sides by root 3, x equals 6. And 2x would then be 12. So the two sides of the triangle were identical to one another, but we just didn't want to make that assumption on our own without knowing for sure. So what's the length of AD? AD is this side right here, and that's this part of this triangle that we're working on. So the answer to number 19 is going to be B. Going over to number 20 now. Okay, number 20 says the graph of y equals d of t could represent which of the following as a function of time from when the wheel began to roll. So time is moving on no matter what, but the y-axis of this graph is just simply going up and down and up and down, right? So the question is asking us which aspect of the movement of this wheel, just imagine as it's moving, it's kind of rotating as it's moving forward. Which part of that is going to be going straight up and down? And the answer to that is this dot. The height of this dot right here, it's at a high point, and as it rolls, it'll get to a low point, and then a high point and a low point again. The horizontal movement just is coming from the fact that time is moving forward no matter what. So it's the height of that mark on the wheel from the ground that's going up and down. The distance of that dot from the center, even as it spins around and around and around, it'll always be the same distance from the center. The distance from its starting point is probably going to be something that increases literally or close to it, because the further, or linearly or close to it, the further this thing rolls, the further that dot is going to be away from its starting point. And the speed at which the wheel is rolling, well, they told us it was a constant rate. So the speed is not going up and down, the speed is constant. So the best answer here, based on process of elimination as well, is choice D. Now we're going to number 21. A is negative and B is positive. Which of the following must be true? Here, I would just go ahead and plug in numbers according to what they're saying. So let's say A is -2 and B is +3. When we plug in numbers, we want to stay away from 0 and 1 as they have their own properties. So A is negative and B is positive, and let's plug that in. So -2 minus 3 over -2 is equal to C. -5 over -2. Double negative is a positive, so this is really 2.5 equals C. So based on what we got, C is a number that's greater than +1. So the answer to number 21 is going to be A. Number 22 here. So an 8th grade class with 26 students was surveyed, 34.6 of them had at least 2 siblings. So the at least is a little deceptive. So we'll say 34.6% had more than, or had equal to or greater than, right? It had at least. It could have had 2 siblings, or it could have had more than 2 siblings. Okay. And the students in Mr. Camp's class are representative of the students in the state. That's really important because in data collection, we're sort of training ourselves to not necessarily feel like one small sample is always representative of the whole larger group unless it was taken out randomly from the entire group. But one class generally wouldn't reflect for the whole country. It would reflect just for that class. But here they're telling us that the class is representative of the state. There are 1,800 eighth grade classes in the state. So what's the total number of students in the state? That's going to be the 1,800 classes times the fact that there are 26 students in each class. So that's another price times quantity statement, if you think about it. So we've got 46,800 total students. And the percent that had equal to or more than 2 siblings is going to be 34.6%. So now what's the question asking us? It's asking us for fewer than 2 siblings. So that's the opposite of this statement right here. So we have equal to or more than versus fewer than. People who are doing this in too much of a rush may overlook that. So if 34.6 has equal to or more than, then the opposite of that is going to have fewer than. So percents add up to 100. So if we subtract 34.6% from 100, we get 65.4%. And those are the ones that would have fewer. In essence, it's every single student that doesn't have equal to 2 or more than 2 would have fewer than 2. So out of the whole state, we've got 46,800 and 65.4% of them have what we're looking for. Now we're going to multiply that in as a decimal because the decimal form of 65% is 0.65. So we have 46,800 times 0.654, which is 30,607.2 for number 22, and that is choice C. So the answer to number 22 is C. And we'll go on now to number 23. The relationship between the monthly rental price and the property purchase price in thousands of dollars. So right now, the most critical thing I'm seeing is that they're speaking in thousands. So that means that our X values are going to be missing these 3 zeros. So for instance, Glenview is 140 because we're talking in thousands. It's 140 in thousands, 140,000. So that's very critical, and not seeing that would cause you to get the wrong answer. So now that we have that, we can figure out our slope. So let's go ahead and just take any 2 points. So maybe when the purchase price, well, okay, just a little doubt over what's X and Y. I'm assuming this is X and this is Y, but we can know for sure because they're giving us Y equals MX plus B. So the X is the P and the Y is the R. So even though it's probably what we were going to do anyway, I'm glad that we confirmed that a little bit. So the two XY coordinates we're getting are 128 and 950. I'm just picking the first two. and also 176 and 1,310. So just getting the slope. Slope is y2 minus y1 over x2 minus x1. And so we can call this x1, y1, x2, y2. And so 1,310 minus 950 over 176 minus 128. Calculate that out. And you get 7.5. So the only answer here that has a slope of 7.5 is choice D for number 23. So now let's go over to 24. '24 is a pretty difficult question. Townsend Realty purchased the Glenview Street property. Okay, let's just delete everything but the purple part there because we need to remember this is in thousands to not make a mistake. But Townsend Realty purchased the Glenview Street property and received the 40% discount off the original price and an additional 20% discount. What approximates the original price? Well, here we have the purchase price. So this is not the original price. This is what happened after the 40% discount and the 20% discount. So the question is going to be baiting us into saying that we have, well, Glenview's right here. So 140,000 and a 40% discount, which means we're keeping 60%, and a 20% discount, which means we're keeping 80%. And that's going to give us our number. But that's actually wrong because what we need to do is tell the story. And stories would not be proper stories if they're not in the right order. So the order is that there was an original price that doesn't show up on this chart because the chart is labeled purchase price. But from that original price, there was a 40% discount, which means we kept 60. And there was a 20% other discount, which means in that moment we were keeping 80%. And when that happened, it resulted in a purchase price of 140,000. So now I'm going to keep the 3 zeros on the 140,000 because even though the chart is in thousands, I need to actually figure out the actual amount of money because look at the answer choices. They're actually giving us the amount of money. It's not 350, which represents 350,000. They're actually giving us the real number. So simplifying down here, we have 0.6 times 0.8, which is 0.48. And dividing both sides by 0.48, you have 140,000 divided by 0.48. And it gives you 291.66 and rounding off to 7. So which of these is closest to that? That's going to be choice B, 291,700. And just one more quick thing before we move on from this question is just the idea that why did we use 60 and 80? Well, with percents, you always start at 100, but if I were discounting 40%, it would take me here, or if I were increasing something by 40%, it would take me here, and then you use them both in decimal form. So this is why we treated a discount of 40% as 60%. Same thing goes for the 20 that was taken off. If you have 100%, you could be increasing it by 20% or decreasing it by 20%. And so we'd be multiplying by 0.80 or by 1.20. And that's what you do with percents. You start at 100, and then you just go ahead and follow the directions from there. And when you have a percent of a percent, then you just keep multiplying. So first we took 40% off, then we took 20% off, and we had a percent of a percent, which is totally okay. So now we can move on to number 25. Very difficult question for number 25. A psychologist set up an experiment to study the tendency of a person to select the first item when presented with a series of items. 300 people were presented with 5 pictures arranged in random order, and we were asked to choose the most appealing picture. Okay, so just reading through a little. Of the first 140 participants, 36 chose the first picture, and then there were 150 more, and P chose the first picture. So once again, let's tell the whole story. They're talking about the percent, and a percent is a part over a whole. So the part that we've been talking about for the first 150, 36 chose the first picture. But for the second 150, there were P there that chose the first picture. But the question tells us that that came out to more than 20%. So 20%, I can write it as 20%. I can write it as, well, percent means over 100, so I could write it as 20 over 100. Or looking at the answer choices, cheating a little off of what we're going to be expected to do later, 20% can also be expressed as 0.20. So right here we have the setup. We have the percent, which they gave us, 36 plus P over 300, and that percent is greater than 20%. So now we can start trying to simplify this to make it look like one of the expressions in one of the answer choices. So we can maybe combine the 150 and 150 to give us 300. Multiply by 300 on both sides. And now we have something that looks a lot closer to one of the answer choices. 36 plus P equals 0.20 times 300. And that's identical to choice D for number 25. So the answer to number 25 is going to be D. Now we're going over to number 26. Okay, 26 is talking about a cube. So let's just kind of draw one here. Not paid for my artistic skills, but that's a cube. Okay, so the surface area, well, first of all, volume would be, if I were to fill this cube with water, how much water would I fill it with? That's volume. Surface area is, if I were wrapping this cube with gift paper, how much paper would I need? So how much area would I need in order to cover the entire surface? But that formula is given to us as 6 times some expression. But the thing to notice is that a cube has 6 faces. Here we've got the 4 faces that go around the outside of it, plus the bottom, plus the top. So those are our 6 faces. So this can be read as, well, this is surface area, and there are 6 faces that we have to get the area of. So we have it as 6 times the area of one face. Would be kind of logical, just considering the fact that this is a cube and it's got 6 faces, and they're giving us a formula with 6 times some expression. So according to what we're saying here, A over 4 squared is the area of one face. Now looking at one face, well, one face could be just like one of these squares here. And if we have one of these squares here, and we're finding the area, what would we do? We would do length times width. And if it's a square, which it is, then we're realizing that those are actually the same. So for a square, instead of length times width, you'll see the area described as side squared. So in other words, length times length, considering that they're both the same number, would be squaring it. So the area of this face is the side length, times the side length squared. Well, what are they telling us here? It's a over 4 squared. So what does a over 4 represent? It's representing one side length. So now that we have that, we can say this length here, in addition to being called S to us, it's a over 4 in this problem. So now what's the perimeter of one of the faces? What's the perimeter of that yellow face, for instance? Well, the perimeter is the distance around, and that square has 4 sides. So there are 4 sides, and each side has a length of a over 4, according to what we figured out. Cancel out the 4's there, and you get a. So the answer to number 26 is actually B. Number 27. The mean score of 8 players is 14.5. The highest one is removed. The mean becomes 12. So let's take that step by step. The average is the sum over the number. So altogether there are 8 here, and the average is 14.5. So whatever it is that goes on the top right here, that's the sum of all 8. But what we're going to talk about really in this question is the concept of average as a repeated number. So for instance, when there are only 7, the mean of the 7 is 12. So I have 12 numbers right there that have an average of 7. We don't know what the individual numbers are, but we do know one thing. If every single one of those 7 players had 12 points, the average would be 12, because the average as a repeated number is kind of easy to figure out. So once again, if 7 of them all had scores of 12, that kind of fits what we're saying, because if everyone had a 12 in this group and I took the average number would be 12. So I don't necessarily know that they each have 7, but I know that I can consider this, or that they each have 12, but we know that we can consider this as if they each had 12. So we've got the 7 things that we're going to count as 12, 7 times 12, plus the one that we didn't count. And that's our equation right there. So the one we didn't count out of the 8 is the score of that 8th one that had been removed. So now we're just solving for x, multiply both sides by 8, and you get 116. 7 times 12 is 84. Take away 84 from both sides, and we have number 30, and we have 32 here. So the 8th score, the one that was removed, is going to be a 32, and the answer to number 27 is C. And now we're going to question 28. Okay, so here we have the function f. So that's the function f, it's a line. The problem tells us about the function g, and g has a slope that's 4 times the slope of f. So what is the slope of f? Well, slope is generally your change in y over your change in x. It's your rise over run as you go from left to right. So if we pick any 2 points that are easy points to work with, the rise is 1 and the run is 2. So from A to B, we have a rise of 1, a run of 2. And so our slope for function f is 1/2. So now that we have the slope for f, we can go ahead and figure out the slope of g, because g is said to be 4 times the slope of f, which was 1/2. 4 times 1/2 is 2, and we now know that the slope of function g is 2. G has a slope of 2, and it passes through 0, -4. So what do we have here? We have a point and we have a slope for function g. And when we have a point and a slope, we use the point-slope formula of a line. y minus y1 equals m, x minus x1. If you don't have that formula memorized, definitely memorize it. By the way, if we were given a slope and a y-intercept, well, the slope-intercept formula is the classic y equals mx plus b. So when you're doing the equation of a line, it depends on the ingredients you get. If you're given the point and the slope, you use the point-slope formula. If you're given a slope and an intercept, you use a slope-intercept formula. So we have a slope of 2 and a point of 0, -4. Let's plug that in. So you have -4 here and 0 there. So just simplifying through, 2 times x and 2 times 0 gives you 0. And you can take away 4 from both sides, and you get y equals 2x minus 4. That's the equation of the line. Now, by the way, we were being given a point and a slope. Were we being given a slope and a y-intercept as well? Well, the y-intercept is where x is 0, and x is 0. So we could have also used slope-intercept, which is y equals mx plus b. And the slope is simply 2. And the y-intercept is simply -4. So 2x minus 4. And we'd get the same equation. So in a lot of situations, you can use point slope or slope intercept, which is this formula right here. In any case, we now know that the equation of the line is y equals 2x minus 4. And that's our g of x if we want to be a little fancy, because y and f of x or g of x, they're all the same thing. But g of x kind of gives you a way to write it that points to the idea that we're going to be plugging in x values. So g of 9 means it's the same function when x is plugged in as 9. So 18 minus 4, and it's 14. So the answer to number 28 is going to be C. And now we're going over to question 29. 29 is going to be a question that is going to, 29 is going to ask us to use the completing the square method to find the equation of a circle. So let's just go ahead and mention what the equation of a circle looks like. That's the equation of a circle. It's like the y equals mx plus b, but for a circle. H comma k is the center, and r is the radius. But we need to use the completing the square method in order to get there. So what's completing the square? It's the idea that we're going to create a perfect square trinomial in order to factor it and to get an equation to look the way we want it to look. And completing the square depends on knowing b over 2, and b over 2 squared. So what's b? Just remember that a quadratic equation is generally in the format of y equals ax squared plus bx plus c. So b is going to be the second number in that sequence. It's the thing in front of the x. And so we're going to have b here in terms of x's. So the thing in front of the x is 20. But another one right here, because in the y squared plus 16y plus some number, the b in that situation is 16. Now, in the completing the square method, b over 2 squared is what you add to both sides. And b over 2 is what it'll factor to after you go ahead and add something to both sides. So that's something that you need to remember. b over 2 squared. b over 2 squared is what you add to both sides. b over 2 is what it factors to. So for the x side, you have 20. Divided by 2, you have 10. And square it, you have 100. For the y's, you have 16. Divided by 2, you have 8. Square it, you have 64. So let's take our original equation. By the way, the number, the constant, the -20, if it had been on the left side of the equal sign, we'd want to add it to both sides or subtract it or do whatever we need to do in order to be able to do the completing the square method. So now we're going to add b over 2 squared to both sides. So we're going to add 100 for this one, and we're going to add 64 for this one. If we added 164 to the left, which we did, it means we need to add 164 to the right to balance it out. So what we did by adding the 100 is we created a polynomial of x squared plus 20x plus 100. That can be solved by BC factoring. What are two numbers that add to 20 and multiply to 100? The two numbers are 10 and 10. So it factors to x plus 10 squared. But based on this formula, we already knew what it would factor to. We knew it would factor to 10. So the completing the square formula is kind of good because it tells you what the answer is going to be in a way. And on some of the harder questions that have to do with completing the square, they give you situations where it's not something as easy as x squared plus 20x plus 100 to factor. It's something maybe with fractions or something that we're not used to factoring, where you have to essentially be able to depend on this method a little bit closer. So y squared plus 16y plus 64, what does that factor to? What two numbers add to 16 and multiply to 64? 8 and 8. But we knew that already as well, right? So this will factor to y plus 8 times y plus 8, which is y plus 8 squared, and you have 144. Now comparing this to the equation of the circle, this would be like saying x minus negative 10 and y minus negative 8. So the center is negative 10 and negative 8. And the radius, well, r squared is 144. So if r squared is 144, square root of both sides says that the r would be 12. So the center is negative 10, negative 8. And if we were asked for the radius, it would be 12. So the answer to number 29 is B. And just bear with me 1 second before we go to number 30. Okay, and now we are going to question 30. Which of the following is an equivalent form of the equation for number 30? Well, this might remind us of a difference of squares. A difference of squares looks like this. So notice that it's got a minus sign, so it's a difference, and it's got two perfect squares. So the name is perfectly accurate. But something like that will always factor to the square root of each piece with a plus sign and a negative sign. And so this is our question here is not a difference of two perfect squares because A is not a perfect square. So a high level difference of squares question is going to kind of ask you to make this happen even when it's not naturally the case. But if what we're doing to do the difference of squares is we're taking square roots, then we can maybe still try to do that in this situation. So the square root of x squared is x. That's a little easier. But the square root of a, we can just write it as square root of a. So x plus root a, x minus root a, and the answer to number 30 is going to be B. Now we're going over to question 31. Horsepower and watts are units of measure of power. They're directly proportional. So a little background, if A is directly proportional to B, that's the statement A equals K times B. And if A is inversely proportional to B, that's the equation A equals K over B. So what's proportionality? And doesn't it look a lot like y equals mx plus b anyway? When things are inverse or directly proportional, there's no y-intercept. So the y-intercept's always 0, and they always pass through the origin. That's just a slight difference between proportionality. And actually, if we're doing inverse proportionality, you're actually not going to have a value at the origin, because if b were 0, then you'd have no solution here. But it's kind of like the regular equations we deal with, but just with a little twist. It's a little awkward of a math concept, which is exactly the kind of thing that College Board would like to ask us about, because it's not difficult per se, but yet a lot of people who haven't been exposed to it are going to get it wrong. And that's what we're here to do for you at Grateful, is to teach you everything you need to know in order to be successful on the SAT. And we could be tutoring you online, one-on-one, regardless of where in the world you live, starting today with a qualified tutor who uses this same curriculum that we're using right now. So let's go ahead and get into this problem a little more. Horsepower and watts are directly proportional. So the horsepower is proportional to the number of watts. Just like if we said A is directly proportional to B, that'd be A equals KB. So horsepower is proportional to watts, so H equals K times W. 5 horsepower equals 3,730 watts. Now, by the way, what's K in all of this? K in inverse and direct proportionality stands for the constant. Once you find it, it's constant. It will not change. So right now, if we do 5 divided by 3,730, we get 0.001. And since this is the calculator section, and since we recommend using a graphing calculator, such as a TI-84, we'd rather have you save this number in your calculator, because 0.001, it's got a lot of digits that are not going to be used there, right? So K is 0.001, so we'll plug that back in. H equals 0.001 times W. Now, if we have 2 horsepower, how many watts? 0.001 W. So W is, now we're going to have to divide both sides by the 0.001, but I'm not just using those 3 digits. I'm doing 2 divided by the 0.001 that's in my calculator stored. And that gives me 1,491.99971. So how much power in watts? Now, definitely a little confusing wording, but when they're saying in watts, they're kind of saying in whole watts. They're saying not to a decimal. So we need to actually take this number and round it to the nearest whole number, which would be 1,492, because the number after the 1 is 5 or greater. So we now rounded it to the nearest integer, and 1,492 is actually the answer in the answer key here. So we're moving to question 32. Okay, so the painting by Van Gogh has a height of 29 and a width of 36.25. Each dimension of the reproduction is 1/3 of the corresponding original. What's the height? So maybe a chart here to stay organized. Height and width, 29, 36.25. And this is in the original. And now in the reproduction, we have 29/3 and 36.25/3, because the reproduction has dimensions that are 1/3 of the original. So what's the height of the reproduction? It's simply 29/3, and a seemingly difficult question actually turned out to be super easy. Let's go over to number 33 now. On PS, PQ equals RS. So let's notate that. PQ is the same length as RS. So what does that allow us to do? If they're the same as each other, then that means that x minus 1 is equal to 3x minus 7. So solving through, take away x from both sides. Add 7 to both sides. Divide both sides by 3. And x equals 3. So it would be very tempting here to plug in 3 as our answer. So whenever you enter an answer in to a question, you're going to want to just double check one last time if that was the thing that was being asked. But PQ is x minus 1, so it's 3 minus 1. QR is x, so it's 3. And RS is 3x minus 7, so 3 times 3 minus 7, 9 minus 7, so it's 2. And the length of PS is 2 plus 3 plus 2. And so the answer to number 33 is 7. Number 34, the point 25 lies on the graph of the function. Okay, so when you're given a point on the SAT, whether it's a straight point like 25 or letters like P comma R, a lot of times you're just being asked to plug it in. So here we have 2 comma 5. So we have f of x equals k minus x squared, and f of x is just your y. So the x is 2 when y is 5. So we plugged in x is 2 and y is 5. Add 4 to both sides. K equals 9. What's the value of k for number 34? It's 9. So going to number 35 now. Landscaper is designing a garden. The length is 5 longer than the width. So we have the length and the width. The length is being built off of the width. So if that means that if the width is x, the length is 5 longer than that, 5 plus x. And what's the area of a rectangle? It's length times width. So it's 5 plus x times x. And the question tells us that the area is 104. So distribute the x into the 5 plus x. Subtract the 104 to the other side and rearrange the terms. You have x squared plus 5x minus 104 equals 0. Now this is a quadratic, and quadratics are solved by setting them equal to 0 and starting with factoring and using other methods if we need to. But we're looking here for 2 numbers that add to 5 and multiply to 104. So what numbers would those be? We can divide 104 by every possible number. 104 times 1, 52 times 2. Let's see if it divides by 3 or by 4. It divides by 4. I know it doesn't divide by 5 because it doesn't end in 0 or 5. Does it divide by 6? By 7? And by 8? It's equal to 13 times 8. Now that's critical because 13 and 8 are 5 away from each other. So the 2 numbers that add to 5 and multiply to negative 104 are going to be positive 13 and negative 8. Just think about it. 13 minus 8 is 5. 13 times negative 8 is negative 104. So now we have it factored, and we have 2 factors here. The zero product rule says when you have 2 things that multiply out to 0, you set each independent one equal to 0. So x plus 13 equals 0, x minus 8 equals 0. And solve each one. Here you get negative 13. Here you get positive 8. And so because we're talking about length, we can't have a negative length. So 13 goes out. And the width is now 8, and the length is 5 plus 8. So what's the length? It's 5 plus 8, and it's 13. So the answer to number 35 is 13. Now we're going to number 36. "36 is telling us that we have 20 degrees here and 20 degrees here. And there are maybe a couple of ways to kind of deal with this question. But one way would be to see it in terms of inscribed angles. So if I have a 20 right here, like we do, we're supposed to know that this arc here on the opposite side that's inscribed by the 20-degree angle is a 40-degree angle. So we can do that in our diagram. We can extend this line out, and this would be 40 degrees. And same thing here. So this is the arc that is inscribed by the angle. So that's 40 degrees. And same thing here. This green arc is the inscribed arc for this angle right here. So that's another 40. So now we've got 40 and 40. So we know that this yellow arc has a total degree measure of 80. So if that is an 80-degree arc right there, we need to also know that in addition to inscribed angles that have a 2-to-1 ratio, central angles have a 1-to-1 ratio. So if I have that same 40-degree arc with a central angle, then I'm going to have a 40-degree angle here. So what we're saying is that a 40-degree arc of a circle is going to cut off a 20-degree inscribed angle and a 40-degree central angle. So with central angles, there's a 1-to-1 ratio. With inscribed angles, there's a 2-to-1 ratio. So according to the fact that this arc, we'll make it a little neater here, this arc right here is an 80-degree arc, then the central angle right here is an 80-degree central angle. Now that 80-degree angle is vertical with the x, so the value of x is 80 degrees. Now there's one more way to solve this question that might be the more popular of the ways. So we're going to go back to the beginning of question 36 and solve it a totally different way. Another thing that we can use the 2-to-1 and 1-to-1 ratios for is kind of saying that if we're talking about this arc right here, then we know that the central angle pertaining to that arc, if this is an x degree arc, then the central angle, let's make it a little more in the actual center of the circle. The central angle is going to have the same degree measure as the arc. So that's going to be x degrees right there. But the inscribed angle, it intercepts the same arc, but it goes to the opposite side of the circle, is going to be half of that. So right now we're finding a different way to express the idea that for central angles, there's a 1-to-1 ratio because these two are in a 1-to-1 ratio with each other. And for inscribed angles, there's a 2-to-1 ratio because this arc has double the number of degrees as this angle right here. So we're expressing the same 1-to-1 and 2-to-1 ratio. But if we do this, we can do one other thing. There are 360 total degrees in a circle. So if we have x degrees in red there, then we can consider this to be the other 360, or the thing that would complete the 360. We can call that 360 minus x. Now think about this. This plus this equals 360. And there's the underlying idea that when two things add together, and I already know what they add to, we can use subtraction. So for instance, if I know that I have x degrees for one angle, and I know that the other angle is the complement of it, then I can call the other angle x minus 90, or 90 minus x rather. And so in this situation, if x was 10, 90 minus x would be 80, and they would actually add up to 90. So this is a way to express the idea that two things add up to a greater whole. Use subtraction. So we've got 20-degree angles here and here. And this is a quadrilateral that we're working with now. It's a four-sided figure. 1, 2, 3, 4. And the four angles of a quadrilateral have to add up to 360. That's something that you're expected to know on the SAT. A quadrilateral has 360 degrees. So now we can say x plus 2 plus 20 plus 20 plus 360 minus x equals 360. Combine like terms. Plus 40 plus 360, so that'll be 400. And here I might multiply both sides by 2. X plus 800 minus 2x equals 360. Combine like terms again. X minus 2x is negative x. Take away 800 from both sides. And I actually see where my mistake was, because when we multiply both sides by 2, we needed to get 720 on both sides. So starting over at that stage, multiply both sides by 2, x plus 800 minus 2x equals 720. Apologies. Combine like terms. Take away 800 from both sides. And multiply both sides by negative 1. And x equals 80. So that's number 36. The answer is 80, and we demonstrated it two different ways. I'd love to hear in the comments which of those ways was your preferred way to do things. Going over to number 36 now. Going over to number 37 now. Miss Simon drove directly from her home to her workplace in 24 minutes. What was her speed? Well, distance equals rate times time, but I'm noticing the h right here in miles per hour. So we have to be a little careful. So the distance is, let's see, it's from home to the workplace. So that's all three of these put together. So 0.6 plus 15.4 plus 1.4, that's 17.4. And the rate is what we're solving for. And we need to take that 24 minutes and convert it to hours, because we already had hours for, we had miles per hour in our rate, in the rate that we're working with, miles per hour. So we're dealing with hours. So we'll go ahead and say 1 hour is 60 minutes. And right here you have the unit minute on the top and on the bottom, so it cancels. And you get 24 divided by 60, which is 0.4. So the amount of time is 0.4 in hours. Divide both sides by 0.4. 17.4 divided by 0.4 is 43.5. And the answer key here says that you could have said 43.5, 43, or 44. but I don't really see how it would be correct to get either of the other two answers. Now looking at number 38, that is a seemingly very difficult question, but there's kind of one way out. So the question says that the travel time from the freeway entrance to the freeway exit increases by 33%. But the travel time for each of the other two segments does not change. So if we want to know how many more minutes this is taking, the other two are not going to change. So we've got from the freeway entrance to the exit, which is this part right here that's changing, but this part is not changing and this part is not changing. So whatever the amount of minutes was going to be for those two blue segments, it's going to stay the same and it's not going to play any role in the change. So we can kind of just compare only for the green part. So distance equals rate times time for what we originally had here, a distance of 15.4 and a rate of 50. So 15.4 miles, 50 miles per hour. And so the original amount of time in hours now is 15.4 divided by 50, which is 0.308 hours. And we can go ahead and convert it into minutes right off the bat here. And that's 1 hour is 60 minutes. So 0.308 times 60, the hour unit cancels, gives you 18.48 minutes. Now we'll do the same thing, although the time is increasing by 33%. So the time is now 18.48 minutes. To increase something by 33%, like we often say here, that gives us 100%. If I increase by 33%, it would be 133%. If I decrease by 33%, it would be 67%. And both of those get put in decimal form. So we have an increase of 33%. So 18.48 times 1.33 is going to give us a time of 24.5784 minutes. So the original time it took was 18.48 minutes. Now we're up to 24.5784 minutes. And how many more minutes means we subtract those two numbers. So 24.5, just using it from the memory on my calculator so I get the exact number, minus 18.48 is 6.0984. Now the question is asking us in terms of minutes. So once again, that's implying whole minutes. So we need to round this 6 to either 6 or 7, and we can round it, we can keep it at 6 because the number that follows the 6 is not 5 or greater. So we'll just say it's 6 minutes. And the answer to number 38 is indeed 6.